is higher. The second part is a little bit bigger than the first one. Okay. So we will divide this unit into two halves. Today, let's focus on second half of this unit because they are not dependent on each other. So they are independent. Because you are direct second year students, you will find this bit easier to understand from exam point of view, because in the very next month you have your insane examination. So let's focus on the second half of this unit. Okay? And all SE students, I'll be sharing on your common email. I'll be sharing all this PPT presentation, which is as good as notes, as well as I'll be sharing some scanned notes with you people. You can also take the notes from second year regular students. And most of all, please refer through all the books given to you. I'm also providing you the handouts, which point to be referred by which unit. Okay, so don't be confused. I know you have your practical exams also, so whatever number of practical we'll be able to complete in the regular lectures, that will be there in your examination. And submission of practical will do it later after your in-same examination, so please do not take tension. You have only few days to appear for your in-semester examination, so I request you to focus to score and pass in semester examination. Simultaneously keep doing practical, and at the end of in semester exam we'll have a practical submission. So let's see what is feedback amplifier. In the previous lecture, we have seen what is an amplifier, MOSFET as an amplifier. We have also seen what is the frequency response of an amplifier. Let me share a whiteboard with you. So we have seen what is an amplifier, a MOSFET as an amplifier. So there we have studied the voltage divider bias method. If you remember, this was our enhancement mode MOSFET. It was having terminals drain. Then this was a substrate or body terminal connected together with the source, and this was the gate. This was your MOSFET. Then we applied voltage divider bias method so that operating point will not get shifted during any portion of the input signal. So the voltage divider bias method, you were having the resistance R1 and R2 here, which used to form a voltage divider network. So this was resistance R1, this was resistance R2. Then there was a drain resistance RD, which was connected at the drain terminal. So this was your RD. Combinedly, you used to apply drain voltage VDD at the drain terminal. So VDD is supplying to the drain through RD as well as to this voltage divider network. Then there was a source resistance RS. We have done DC analysis of this circuit. We have plotted DC load line also. Okay. Then while if you want to use this circuit as an amplifier, you have to apply input signal. This was AC signal. Okay. And the AC signal was given through the capacitor, because capacitor allow pure AC to pass to the amplifier. So this was your input capacitor C1. Then you take the output through another capacitor so that you will only get the pure DC at the output. So this was your capacitor C2. And if you remember, we have connected here a bypass capacitor CS. So this bypass capacitor bypasses the AC signal and does not make that AC signal to drop across RS, and therefore it reduces the output voltage. It increases the output voltage, it increases the gain, right? So this was your amplifier. Now, if you connect here a capacitor, what is happening that your AC signal is getting passed. We call it as a bypass capacitor because it provides a bypass way for the AC signal. So AC signal will get passed to the ground. It will not drop across RS, and therefore there is no signal voltage which is mixing to the input. This is your gate voltage VG. This gate voltage is comprised of one way. This voltage is voltage across R2 and it is same as voltage VGS between gate and source and the voltage across RS if you apply KVL in this loop. Okay. So because we are connecting here a capacitor, it means that AC voltage is absent here. So if you apply KVL in the input loop, you will find that no AC voltage is mixed with the input signal. So it means there is no feedback. But if you remove this capacitor, AC signal is going to drop across this resistance, which is reducing your output voltage. And if you apply KVL in this loop, you will find that the total gate voltage is now made up of this VGS as well as AC voltage across RG. So what is happened here? Output voltage, there was a current flowing, AC current was flowing, it has dropped some voltage and this voltage has been mixed in series with the input. Okay, so we call it as a feedback. Now let us understand what is a feedback. When I say the term feedback, feed means feed the part of output back to the input. Feeding part of output back to the input is called as feedback. Okay. Now let us understand the general structure of a feedback amplifier. So when you apply feedback, when you take the part of output of amplifier and apply it back to the input, we call the process as a feedback. Okay, so we call this process as a feedback. So what is there in the feedback amplifier? So look at this structure. I'll be using this as a whiteboard. So you have an amplifier. Okay. This is your amplifier. This is your amplifier. I'm drawing it on the right hand side. Please note it. So this is your amplifier A. So you provide here some signal, input signal, let's say Vi. And this amplifier amplifies it and provide the output Vo. Then what you do, you take some part of this output. Okay? You take some part of this output and provide it back to the input. So you have taken some part of the output. What part you have taken? Either you can take voltage or you can take current. So taking the part of output means sampling is done by this feedback network. Let's say that there is a network called as feedback network. It is taking some part of output voltage and applying it back to the input. Now what will happen at the input there? The mixing of the applied signal with this feedback voltage will happen and it will provide the total input to the amplifier. So basically there is an amplifier. Without amplifier, I will denote the gain of amplifier as, if I want to say voltage gain, I will say it AV. And after applying feedback, I will call this as AVF, gain with feedback. So what is a feedback? So look here. Look here. This is your amplifier. Look at the spotlight. This is your amplifier. Okay. When I talk about only this block, I will say this is an amplifier without applying any feedback. So this is amplifier without applying any feedback, only this part. This is amplifier without feedback. Now, this amplifier is receiving a signal from a source directly. Access. It is receiving signal from this source. Okay. It will amplifying. It is amplifying and provide the input, output to the load. If you want to give feedback, what is done? The output voltage, the output which is given to the load, some part of it is provided to the feedback network. Beta indicate here a feedback. Okay. So there is an amplifier, and the output of the amplifier is treated as XO. Look at this signal output. X stands for the signal. output signal as XO. Suppose the gain of the amplifier is A. Let's say that gain of amplifier is A. If I say this is amplifier without feedback, this is an amplifier without feedback, so I will call its gain as A. It may be AV, voltage gain, it may be AI, current gain, it may be transconductance gain or transresistance gain. What is that? I will let you know. So remember, A indicate gain without feedback. So this is an amplifier and its gain without feedback is A. Remember always, gain is equal to ratio of output parameter to the input parameter. So if I call this as a voltage gain, I will say it is the ratio of output voltage of an amplifier to the input voltage of an amplifier. Output voltage upon input voltage. If I say current gain, then it is the ratio of output current to input current. So gain is the ratio of output parameter to the same input parameter. Okay. So let's now what we will do in feedback, we have a source which is providing you a signal access. You have a source, okay, signal source. It is providing a signal access. We give this signal to a mixer and then it is passed to the amplifier. So output of mixer becomes input of the amplifier. So what amplifier will do? It will provide the output signal. What is the relation between input and output? Suppose A is the gain. I will call output signal as XO. So ratio of XO upon XI is the gain of the amplifier. Okay, it's the gain of the amplifier. XI is the signal received by the amplifier. So it will provide you gain equal to XO by XI. Therefore, what is your output signal in terms of gain? It is A times XI. Suppose gain of amplifier is 10, then you will get the output signal 10 times the input signal. If gain is 100, you will get the output signal 100 times the input signal. Okay. So this amplifier will provide the signal XO, which is equal to A times XI. What beta network or feedback network will do? Feedback network, this is nothing but a feedback network. Beta is the feedback factor, also called as feedback gain. So this part of output is given to the feedback network. So XO is going to the feedback network and it is providing you the output signal XF. What is the input of a feedback network? Output of an amplifier becomes input of the feedback network. XO is the output of amplifier, it becomes input of the feedback network and feedback network is provide a signal which is called as feedback signal XF. Now this is given to your mixer. This is your mixer. Mixing process is happening. So the input signal and the feedback signal are mixed. Okay, they are mixed here in the signal. Now suppose the input signal, so the input signal XS and the feedback signal XF, they are in phase. They are in phase. Then the feedback signal, the input to amplifier becomes XS plus XF. What big XI काय होता? XS plus XF. If the feedback signal and the input signal both are in phase, then we call that feedback as a positive feedback. Remember the definitions of positive feedback. There are two types of feedback. First is positive feedback and second is negative feedback. Type of feedback I am telling you. First is positive feedback, second is negative feedback. So if the input signal and the feedback signal are in phase, it is called as positive feedback. Then what will be negative feedback? Can anyone define? If the
Out
input,
of phase.
right, if the input signal, this is your input signal and the feedback signal, they are out of phase, then it is called as negative feedback. And in that case, your input signal XI is input of an amplifier. It will become XS minus XF. XS minus XF. If they are in phase, they are additive. If they are out of phase, they will be subtractive. So remember, there are two types of feedback. One is positive feedback, another is negative feedback. How you'll define positive feedback? If the input signal and the feedback signal are in phase, then it is a positive feedback. If they are out of phase, then it's a negative feedback. Okay. So now let us see the gain. Again, I will derive here. We have defined gain without feedback as this is amplifier, it is receiving input signal and it is providing output signal. So its gain will be output signal XO upon input signal XI. Right? And if I want to calculate the gain with feedback, then AF is equal to this will be the input signal. Okay. Now for a positive feedback, what is Xi equal to for a positive feedback? This Xi is equal to input signal plus feedback signal. Okay. Therefore, from this I can say Xs is equal to Xi minus Xf. So in this case, my equation 1, that is gain with feedback, will become XO upon my Xs is what? This Xs is Xi minus Xf. Xi minus feedback signal. Let's divide. This is gain with feedback. Which feedback I am applying? Positive. So AF will become, let's divide every term by Xi. So it will become XO upon Xi divided by Xi upon Xi. Divide each term by same will not affect it. Xf upon Xi. So this will give me XO by Xi. What is XO by Xi? It is A. XO by Xi is A. That is the gain without feedback. This is big XO upon Xi. This numerator is becoming A, is nothing but A. Xi by Xi is 1 minus Xf upon Xi. Xf upon Xi. What is your Xf feedback voltage? Okay. What is beta? This is feedback network and the gain of feedback network. Look here. Look here. This is the feedback network. Gain, this is also called as beta network, where we call beta as either feedback factor or it's a feedback gain. Both are same. Okay. So it's a feedback factor or feedback gain. This beta. Now, what is this beta? It's a gain, and you know, gain is always the ratio of output to input. So, beta is also gain. Beta is also gain. So, I can say beta is the gain of feedback network. So, what is the output of feedback network is XF. So, gain is always ratio of output to input signal of that particular amplifier or network. So, its output signal is XF and input signal is what? XO. Okay. Therefore, what I can say? From this, I can say the feedback signal is equal to beta times XO. Okay, feedback signal is equal to beta times XO. So that is why it is written here XO is equal to beta times, sorry, XF is equal to beta times XO. So this XF in this equation, come to the right hand side. Look here. Look here on the right hand side. I am using a highlighter. Okay. So here, this XF I am now going to replace by beta times XO. So my AF feedback gain will be equal to A. Shall I write it on the left hand side? I'll use right here. So feedback gain is equal to A upon 1 minus this XF I am replacing by beta times XO divided by XI. Again, if you see this ratio XO upon XI is nothing but A. So feedback gain is equal to A upon 1 minus this XO by XI is A. So 1 minus A into beta. This is the feedback gain in case of positive feedback amplifier. Okay, which type of feedback I explain you? Look here, my input signal is XS is equal to XS plus XF, right? It means this is a positive feedback. So gain of positive feedback is A upon 1 minus A beta, where A is what? A indicate, what does A indicate? Gain of amplifier without feedback. Beta is the gain of feedback network, and remember beta is always between 0 to 1. बीटा का है फीडबैक गेन है and the ratio of out feedback signal upon the output of amplifier, which is nothing but input of beta. At the max you can take complete output of feedback network and you can apply the complete here, so this ratio can maximum become 1. So beta lies between 0 to 1. So if you see, the denominator is 1 minus a beta. Okay, for a positive feedback amplifier, this is 1 minus a beta. Beta lies between 0 to 1. So the denominator is less. It means the ratio is high. AF is high. It means gain of positive feedback amplifier is very high. Gain of positive feedback amplifier is very high. Now, if you derive this gain equation for a negative feedback amplifier, what are the changes? Let's derive it for the negative feedback amplifier.
Ma'am,
Yes.
AF is equal to A upon minus beta A beta गेन
Yeah.
इंटू बीटा तुम्ही दाखवलेलं
Hmm.
ते एक वेळ एक्सप्लेन करा ना त्याच्या आधीची स्टेप आणि ते
Yes. Now same I will repeat for negative feedback amplifier, okay? Because these things are erased, then you tell me where was your doubt. For negative feedback amplifier, the same steps are there, okay? I'll writing it for negative feedback amplifier. Please let me know, same steps I'm repeating. For a negative feedback amplifier, uh, output of amplifier is XO and input is XI, okay? And XI is receiving two signal XS and XF. Its combination is XI. I'll writing the same thing for negative feedback amplifier. What is Xi? Input given to the amplifier, and it is XS plus is the combination of two signal XS plus XF. In case of negative feedback amplifier, you know the feedback signal is out of phase, so I am going to write minus signal with XF. In the previous derivation, I used here plus sign. So xi is equal to xs minus fi x. Okay. Now, what is the gain of amplifier without feedback? It is output of amplifier xo divided by input of amplifier x. And in case of feedback, the feedback gain is output signal and the input signal xs. So xi is going to change. जेव्हा मी विदाउट फीडबॅक म्हणते तेव्हा ॲडिशनल मिक्स झालेला सिग्नल नसतो, फक्त xi बिकम्स एक्सेस. पण फीडबॅक दिल्यानंतर एक्सेस सिग्नल बिकम्स समथिंग डिफरंट. व्हॉट इट बिकम्स? सो हिअर यू कॅन कॅल्क्युलेट. आफ्टर गिव्हिंग फीडबॅक जर फीडबॅक नसेल तर ही टर्म येणार नाही. इफ देर इज नो फीडबॅक मीन्स एक्सेप विल नॉट बी देअर अँड xi इज इक्वल टू एक्सेस. But if feedback, then there is the term xf present. Okay, the term xf is present there. So from this I can say xs is equal to xi plus xf. Okay. Now what is my feedback gain? In case of negative feedback, it will be xo divided by, let's put value of xs. Call this as 1. Call this as 2. So it will be xo upon xi plus xf. Again we will divide every term by xi. All the terms, if they are divided by same, it will remain unchanged. Divided by xi upon xi plus xf upon xi. This can be written as, what is xo by xi? It is a. So I will write this as a. Xi by xi is 1 plus xf upon xi. Okay. Now this xf, I will replace it by, what is your xf? Beta times xo. Look here. xf is beta times xo. So I'll replace it. So your feedback gain is equal to a upon 1 plus, instead of xf I'll write beta times xo divided by xi will remain same. Again this xo by xi is nothing but a upon 1 plus this ratio is nothing but a. So I'll write this as a into beta. What is a? Is the gain of amplifier without feedback. Now if you look at this expression, your feedback gain in case of negative feedback amplifier is a upon 1 plus a beta. It means 1 is added in a beta. You can neglect this 1 because as compared to this term, or you see here the denominator is greater than the numerator. This is a beta plus 1. So the denominator is becoming higher. Denominator is increasing, therefore gain is decreasing. What we have seen, is your doubt clear? The steps before this, somebody asked me a doubt.
Yes, ma'am.
Okay, the same steps are here, only there is one difference. Here your xi becomes in the positive feedback amplifier, this xi become x plus xs plus f xf. Here it becomes minus. Okay, so in case of feedback gain, you get the gain of feedback equal to a upon 1 plus a beta, which is very small because the denominator is a little bit higher. Okay, so gain is less in case of negative feedback amplifier and it is very high in case of positive feedback amplifier. Are you getting the important difference? In positive feedback you get higher gain and in negative feedback you get lower gain. Now whenever you say amplifier, it should have a very high gain, right? But still we do not apply positive feedback in the amplifier. Why? Because for a positive amplifier there is only one advantage, that it is having higher gain. right? But for a negative feedback amplifier, there are multiple advantages. Only one disadvantage, that its gain is lesser. Okay. There are, what are those advantages? See, there is an important parameter that you have to learn in case of amplifier. When you say amplifier, you need higher bandwidth. What is the job of amplifier? It amplifies frequency. Okay. So more frequency it is able to amplify, better is your band feedback, better is your amplifier. So remember one thing, that the gain and bandwidth product is always constant. Gain into bandwidth, this product is always constant. So in case of negative feedback amplifier, as this gain decreases, bandwidth has to increase. It means negative feedback amplifier amplifies more range of frequency. This is the advantage, because gain bandwidth product is constant. So as gain is increasing, if you consider this as a positive feedback amplifier, so gain will increase, so bandwidth will decrease there. Okay. So what is the advantage of negative feedback amplifier? Because gain decreases, bandwidth increases. Now see, there is noise is present everywhere. Along with the signal, noise is also getting amplified by the amplifier. But if the gain is decreasing, the gain decrease झाला, तर noise सुद्धा, the quantity by which noise will amplify, that will also decrease. So noise level is also minimized in negative feedback amplifier. Then another advantage of negative feedback amplifier, that gain is stabilized here. Stabilization of gain. What is meant by stabilization? The gain is dependent on multiple parameters because of what it can change. So these changes are minimized. Okay, these changes are minimized. How these changes are minimized? Let's derive here. I will try to show this. Just now we had derived an expression for feedback gain, and this feedback gain is equal to A upon 1 plus A beta in case of negative feedback amplifier. Okay. Let us differentiate both sides with respect to A. Let us have differentiation, because we have to find changes in the gain. Okay. After finding changes in the gain, we have to prove that the changes are minimized in negative feedback amplifier as compared to changes without any feedback. हा एक amplifier आहे. Without any feedback, you will find this gain is little bit changing. But after applying negative feedback, you will find the changes taking place in the gain are minimized. It means the gain is stabilized, stable होणार आहे gain. So let us prove it mathematically. We have this equation. Let's differentiate with respect to A. I'll differentiate with respect to A. So what I'll get? DAF upon dA. I have differentiated with respect to A. This is equal to, let's differentiate this right hand side. So it will be 1 plus A beta. This U by V rule I will apply. So it will be 1 plus A beta, that is your denominator, and derivative of numerator. So that will be 1. This is A. So that will be 1 minus derivative of this will be beta into numerator. U by V rule is applied here. Divided by 1 plus A beta square. So this is nothing but mathematics we have applied. So if I solve this, okay, this A beta will get cancelled and there will remain 1. Okay, it will become 1 plus A beta minus A beta. So this A beta will get cancelled, and I will get 1 upon 1 plus A beta bracket square. What is this? DAF upon DA. Changes taking place in AF with respect to changes taking place in A. So from this I can say that DAF, changes taking places in gain with feedback, is equal to, I will take this here, DA, changes taking place in A divided by 1 plus A beta square. So changes in the gain with feedback is equal to, it is reduced. हे कमी झाले, कसे कमी झाले तर changes taking place in gain without feedback, that is DA, gets divided by this factor. Okay, or ultimately you can say कि DA किती आहे, changes taking place in amplifier, in the gain of amplifier without feedback, we denote it by DA. So this DA is equal to 1 plus A beta square multiplied by DAF. So this is at higher side and this is at lower side. Okay, so now I will now again differentiate. I will say that DAF, this DAF, let's erase this, I'll erase this. DAF, changes taking place in amplifier's gain with feedback, it is now denoting it completely, is equal to this DA, that is changes taking place in the amplifier without feedback multiplied by mod of 1 upon 1 plus A beta bracket square. So changes in the amplifier after applying feedback get minimized as compared to changes without apply. So gain जो आहे हा it depends on many factors like temperature, right, is one of the factor because of which gain changes with the operation of an amplifier. तर हे जे changes आहे, if you apply feedback, negative feedback, these are minimized by these factors. कुठल्या फॅक्टरनी 1 प्लस ए बीटा स्क्वेअर एवढ्या फॅक्टरनी ते कमी होतात. जर ए मध्ये चेंजेस होत आहे amplifiers gain without feedback, तर इफ यू अप्लाय फीडबॅक, हे जे चेंजेस असतील, व्हेरिएशन असेल, हे कमी होईल. सो दिस इज अनदर इम्पॉर्टंट ऍडव्हान्टेज ऑफ गेन विदाउट फीडबॅक, सॉरी गेन विथ फीडबॅक. सिमिलरली आय हॅव गिवन यू अन इम्पॉर्टंट ऍडव्हान्टेज की नॉईज जो आहे हा कमी होणार आहे आणि बँडविड्थ जी आहे ती वाढणार आहे. So bandwidth is again going to increase. Similarly, there is happening some changes on the input and output resistance. By selecting suitable configuration, you can select the proper value of RI and ROs. Now let's move further. Is it clear? What is the gain and what is the gain in case of both types of feedback? What are the advantages of all types of feedback? Sorry, what are the advantages of negative types of feedback amplifier? एवढं लक्षात आलं? Yes or no?
येस मॅम. मॅम तुम्ही
Is it?
बोलले स्टेबिलाईज असतं ते, बट फीडबॅक यूज केलं की स्टेबिलायझेशन नसते ना.
फीडबॅक यूज केल्यानंतरच स्टॅबिलाइज होतो. स्टॅबिलाइज होणे म्हणजे काय, जे व्हेरिएशन्स असतात गेन मध्ये होणारे, तुम्ही एका अँप्लिफायरला एक सिग्नल दिला, त्याचा आउटपुट सपोज त्या अँप्लिफायरचा गेन 10 आहे. ओके, सो 1 वोल्ट तुम्ही दिला तर यू एक्सपेक्ट 10 वोल्ट, बट बिकॉज सम चेंजेस द गेन हॅज ड्रॉप टू 9, so your output will be 9 volt, or gain has increased to 11, your output will be 11. So there is variation. हे जे variations होतात, हे we don't want that, it is not desirable. Okay, so if you apply gain, these changes, they are reduced as compared to the previous case. रिड्यूस झाले, म्हणजे पहिले 1 वोल्टचा चेंज होत होता आउटपुट मध्ये, तर आता 0.1 चा चेंज होऊ शकतो. सो द चेंजेस आर मिनिमाइज, इट मीन्स गेन इज गेटिंग स्टॅबिलाइज. चेंजेस कमी होणे किंवा नील होणे म्हणजे स्टॅबिलाइज होणे, कॉन्स्टंट राहणे. गॉट इट? हे चेंजेस होतात, दे आर बिकॉज Now we are moving on the fast track. There are many parameters because of which your gain changes. Okay, I'll share you the video recordings previously. You can access it. So detail we have already discussed. We are moving on the fast track. Have you understood that there are the gain changes of amplifier because of some reason, and that changes are reduced? If you see the equation, हे इक्वेशन बघ. फीडबॅक अप्लाय नंतर जे चेंजेस आहे DAF, we call it this as DAF by F, that is equal to जे changes without feedback होणार आहे that gets divided by 1 plus A beta square. या फॅक्टरने ते डिवाइड झालाय म्हणजे तो कमी झालाय. DA किती आहे तर DA हे 1 plus A beta multiplied by AF केला तर multiplication means DA is higher and DF means DA gets divided by this, it means DF is lower, म्हणजे चेंजेस जे आहे कमी आहे. अंडरस्टूड? येस और नो? अंडरस्टँड दिस मॅथमॅटिकल इक्वेशन?
Yes, ma'am.
कळलंय का?
Yes,
Shall
ma'am.
we
Yes.
move further? So I told you the advantages of negative feedback amplifier. It is mentioned desensitized gain. Gain is less sensitive to circuit component variation. Changes in the circuit components, changes in the temperature, all these factors are going to affect the gain, but these are reduced in case of feedback amplifier. Control input and output impedances by applying appropriate feedback topology. Now this we will going to learn in detail. इनपुट इम्पेडन्स आणि आउटपुट इम्पेडन्स तुम्हाला हायर पाहिजे लोअर पाहिजे हे तुम्ही पर्टिक्युलर टोपोलॉजी सिलेक्ट करून यूज करून सिलेक्ट करू शकता. Bandwidth of amplifier increases, noise effect reduces, and reduce non-linear distortion. What is non-linear distortion? This is one kind of distortion because of which हार्मोनिक्स आर काय होतं की आउटपुट सिग्नल जो आहे तो तुमचा तेच पाहिजे जी इनपुटची फ्रिक्वेन्सी आहे. बट इन द एम्प्लीफायर यू गेट other than that you get multiple integral of input frequency also. These are the non-linear distortion. So one I told you, one of this is harmonic distortion. तर हे पण फीडबॅक अप्लाय केल्यानंतर रिड्यूस होतात, कमी होतात. Now come back. This point number 2 will control input and output impedance. This we are going to talk in detail, and a question you will find based on that. So now let's see what are different types of amplifier. Actually these amplifier and based on what type of feedback you are applying. Here onwards remember आपण शिकत आहोत negative feedback amplifier. Okay, negative feedback has its special application as an amplifier, whereas we use positive feedback in oscillator. ऑसिलेटर मध्ये कुठला फीडबॅक वापरतो? पॉझिटिव्ह फीडबॅक. आणि एम्प्लिफायर मध्ये नेगेटिव्ह फीडबॅक. सो there are 4 basic types of amplifier: voltage amplifier, current amplifier, trans conductance, and trans resistance. So these are some different names given. Now we will learn the basic topology and we will also label हे जे 4 amplifiers चे type म्हटले, we will label here itself. Okay, so feedback topologies. In the feedback amplifier, I told you that we used to take some part of output and then we mix it at the input. So depending on that, what happens in the feedback amplifier, at the output side, sampling happens. Just a minute. This is output side. At this side, what happens is sampling. This is sampling. Sampling means taking part of output. So either you can take voltage or you can take current. So the sampling is happening here. इथे sampling होता है. कुठे होतं sampling? Output ला. Okay, what you can sample? Either voltage or current. Where is sampling taking place? Please reply. Where the sampling is going on? Input side or output side of an amplifier? Hello, sampling कुठे होत आहे? This is your amplifier, high amplifier. This is the output side. Sampling is taking place at the output of amplifier. So you can either sample voltage or current from the output, and then beta network will take some either voltage or current. So sampling is of two types, voltage sampling and current sampling. And then it is mixed at the input. So where the mixing is taking place? Mixing कुठे होते है? Input side or output side? Answer fast.
Input side.
Input side. So you can either mix voltage, no, like that I will tell. You can either have series mixing or shunt mixing. Mix जर तुम्ही voltage sample केलंय आणि mix पण voltage करताय. Remember here one important thing. Mixing can be of two types. One is series mixing and another is shunt mixing. Okay, series and shunt mixing. When you say it is series mixing, you are actually mixing the voltages, this voltage and this voltage. जर तुम्ही voltage mix केलं तर series mixing असते, or I'll say series mixing मध्ये voltage mix केले जाते. And when you say shunt mixing, so to form a shunt node, shunt म्हणजे node form होतो, so that time you are mixing the current. So if you say mixing, सॅम्पलिंग मध्ये काय काय सॅम्पल होतात? एक तर करंट, सेकंड इज voltage, right? You can sample current or voltage, then you can mix this. So mixing means either you can mix in series or you can mix in shunt. So when you say you are mixing in series, you are actually mixing voltage, and when you say you are mixing in shunt, you are actually mixing current. Okay, so what are two types of sampling? Everybody unmute and tell answer. What are two types of sampling?
Voltage and current.
Current and
Voltage
Shunt
voltage.
mix and
sampling, correct.
shunt
And
mix.
what are two types of mixing?
Series and
Okay, now I will, what I'll do, I'll sample current. Okay, I will sample current. I'll sample current and mix in mixing method. I will prefer series. Then I can sample current and I can mix in series. So depending on that, again I can sample voltage and I can mix it in series. I can sample voltage and I can mix it in shunt. So there are four possible way to form the feedback amplifier. What are that? Voltage series. How to I can sample voltage. Voltage is sampled. So first name of amplifier you write as what is sampled. त्याच्यावरून पहिलं letter. And it is mixed in series. Voltage sampled, series mixing. Then you can sample voltage. Voltage sampled, mixed in shunt. Then what you can do, you can sample current, sampled and mixed in shunt series. Then you can similarly you can have current sampled and shunt mixing. So there are four possible combination, or I'll say four feedback topology. What are these called as? Feedback topologies. What are the four feedback topologies? One, voltage sampled series mixing, voltage sample shunt mixing, current sample series mixing, current sample shunt mixing. So feedback किती प्रकारचे पॉसिबल असू शकतात? सॅम्पलिंग काय करता आणि मिक्सिंग काय करता? So there are four ways you can form the feedback: voltage sample series mixing, voltage sample shunt mixing, current sample series mixing, current sample shunt mixing. Okay, got it? Yes or no?
Yes, ma'am. Got it.
Types you understood?
Yes, ma'am, got
Now,
it.
any question?
No, ma'am.
Okay. Now, when you want to sample voltage, where the sampling is taking place? At the output side. So, I have drawn here four configuration: amplifier, feedback network, amplifier, feedback network. Okay. So, look at the first. Whenever you have to sample voltage, you have to connect beta network. Whenever you have to sample, this is your amplifier and this is your beta network or feedback network. Amplifier and feedback network. I am telling you about sampling. So sampling is taking place at the output. This is output of amplifier and this is input of beta network. Beta network take its input from the amplifier's output. So when it is a voltage sampling, remember the beta network is connected in shunt with the output. व्होल्टेज सॅम्पल जर करायचं असेल तर व्होल्टेज साठी जे काय लोड आहे असणार आहे इथे त्याच्या पॅरलल मध्ये तुम्हाला बीटा नेटवर्क करायचं आहे. Okay, if you want to measure voltage across some resistance, you have to put your multimeter across it in parallel with that. Therefore, for sampling करताना voltage जर sample करायचं असेल, so you are connecting beta network in parallel with the output of amplifier. Okay, for voltage sampling. And if you want a series current sampling, तर current कसा flow होतो? Current हा series मध्ये flow होतो. So whatever I had drawn, you can see it here. Look at this figure, how they are connected. Amplifier and beta network are connected in shunt. Okay, here at the output side of amplifier. So this is voltage sampling. हे कुठलं sampling झालंय? हे voltage sampling आहे. हे voltage sampling आहे. Okay. Similarly, in which figure you can see voltage sampling? चार पैकी आणखी कुठे दिसते तुम्हाला? This one दिसते का इथे व्होल्टेज सॅम्पल झालेला फीडबॅक नेटवर्क आणि बीटा नेटवर्क पॅरलल मध्ये दिसतात का या फिगर मध्ये? येस ऑर नो? येस ऑर नो? इन दिस इज इट पॅरलल कनेक्शन? हे पॅरलल कनेक्शन आहेत का? फास्ट प्लीज रिप्लाय फास्ट.
Yes, yes, ma'am.
No, ma'am.
इज इट पॅरलल कनेक्शन?
No.
नो. इज इट पॅरलल कनेक्शन?
No.
येस ऑर नो? हे पॅरलल कनेक्शन आहेत का? हायलाइटर बघा माझं कुठे?
No. No.
स्पॉटलाइट. नो. दिस वन?
Yes.
Yes, this is parallel connection. So here also what is sampled is व्होल्टेज सॅम्पल, इथे पण व्होल्टेज सॅम्पल झालेलं आहे. Okay, this here also voltage sampling is done. In this case, if you want current to be sampled, then your beta network and output of amplifier shall be connected in series. They shall be connected in series. So if this is your amplifier, this is your beta network. So this is the output of amplifier. This is output of beta network. So here there will be some load, amplifier, beta network. Okay. So they are connected in series. Of course, there is some load resistance. So look here. So in that case, how the current will flow? Current sample झाला म्हणजे काय? From amplifier through the load, it will go to the beta network. It will complete the loop. Then it will flow like this. Okay. या loop मध्ये असा current flow होणार. So it is current sampling. So when you have to perform current sampling, you have to connect the feedback network and beta network in series at the output of amplifier. So look here, series connection. Look here, series connection. So what is sampled here is current sampled. या केस मध्ये इथे voltage sample. Similar things will happen at input. If you want to mix in series, so your connections are series. Look here, series connection आहे. इथे सुद्धा series connection आहे. In series mixing, you will find VS signal and VF signal, they are mixed in series. Okay. But I told you in series what we are mixing is the voltage. So you look here, this is VS and VF, they are mixed. VS and VF are mixed in series. And when it is a shunt, so you will find currents are mixed. म्हणजे इनपुट करंट, आता बघा इथे इनपुट व्होल्टेज सोर्स जो आहे त्याच्याऐवजी करंट सोर्स आहे. हा करंट सोर्स आणि IF they are connected in parallel. Parallel connection. Here also parallel connection. So in the shunt mixing, you will find output of beta network and input of amplifier are connected in shunt. And in series mixing, input of amplifier and output beta network, they are connected in series. Okay. So there are 4 types of configuration: voltage series, voltage sampling, current series mixing, voltage sampling, shunt mixing. In short, how we will label this feedback topology चे नाव, the same you can call as amplifier's name. So voltage and series. So first letter indicate, when I write here voltage, first letter indicate how, what is sample. आणि दुसरं indicate करता how it is mixed. So I can write voltage series feedback amplifier. Similarly, voltage shunt feedback amplifier, current series and current shunt. First indicate, the first word indicate how it is sampled. Second word indicate how it is mixed. So there are 4 types of feedback topologies. आता कुठल्या टोपोलॉजीला काय म्हणतात? 1-2 मिनिट, I will just. Now you understood. Tell me here, what is sampled in this figure? Voltage or current? Voltage or current sample?
Voltage.
Here,
Current.
Current.
here,
Current.
here,
Voltage.
इथे voltage. Okay.
Voltage.
How it is mixed? Mixing कशी आहे इथे?
Series.
Series. इथे?
Parallel.
Parallel.
Correct. Series is here. Everybody.
Series.
Series.
Good. Here.
Parallel.
Parallel.
Very good. Okay, now you understand. When you are mixing in series, you are mixing voltage. When you are mixing in shunt, you are mixing current. Now I will write what is the input of amplifier. This is feedback topology. आता हे झाले feedback. This is combinedly a feedback amplifier. हा झाला एक amplifier. This is an amplifier. This is an amplifier. Now what is the name of this amplifier? Let's see. What is the output here? Output sample करतोय, voltage sample करतोय म्हणजे output is voltage. आणि series mixing करतोय, we are mixing it series, so input is also voltage. Look here, what we are sampling? Current I. How we are mixing? We are mixing in series, it means voltages are mixed. Look here, व्हॉट वी आर सॅम्पलिंग? करंट, म्हणजे आउटपुटचा करंट आहे. आणि मिक्सिंग जे आहे हे शंट आहे, म्हणजे इनपुटचा सिग्नल हा करंट आहे. हिअर वी आर sampling voltage, means output signal is voltage, and we are mixing in shunt, means input signal is current. Okay. Series mixing means voltage signal. Shunt mixing means current signal. Okay. So at this you will find output is voltage. Output is voltage and input is also voltage. So this is called as a voltage amplifier. Because for this amplifier, both the signals are voltages. So I'll call this amplifier as voltage amplifier, and its gain, feedback gain, or I'll write its feedback gain as ratio of output voltage upon input voltage. And this is a voltage amplifier. Means when I say voltage series feedback topology is nothing but the voltage amplifier. Look here, the bottommost right side. Output is current, input is current. So this will provide me current gain. Ratio of output current upon input current. So this is a current amplifier. This is a current amplifier. Means current shunt topology is nothing but current amplifier. Now look at this amplifier. Okay. Look at this amplifier. What is the output signal? I will write the gain of this amplifier. First, what is the output signal? Current. What is the input signal? Voltage. Look at this amplifier. What is the output signal? Voltage. What is the input signal? Current. You know what is the ratio of V to I? Ratio of V to I is resistance. So this amplifier is called as trans resistance because output, ratio of output to input parameter. So trans word comes. So this amplifier is called as trans resistance amplifier. Trans resistance amplifier. Okay, and its gain is given by Rm. And this is the opposite of this is the opposite of resistance, I by V ratio. It's a conductance. So we call this as transconductance amplifier. So this is voltage amplifier, this is transconductance amplifier, this is trans resistance amplifier, and this is a current amplifier. Got it? So please revise this, and in the next lecture we will complete the second half of the unit and we'll switch. That will be only able to do. Okay, so we'll stop here. Let me